Hi, everyone. Welcome to TMLS 2024. This is the last day and the second last speaker of the afternoon. My name is Mark Donaldson. I'm the founder and CEO of Chowdhury Analytics. We make edge IoT smart sensors for the commercial trucking industry. We deploy ML models to perform inference for brake measuring and compliance. So today's speaker is Debadyuti Chowdhury, VP Products, InfinyOn. Deb leads product management at InfinyOn, a distributed streaming infrastructure company. Deb's career since 2006 spans across IT, server administration, software and data engineering, lead data science and AI practices, and product management in health tech, public safety, manufacturing, and e-commerce. Take it away.
Thank you. All right. Since the clicker is not working, please bear with me. I'm walking around a little bit. As was announced, I go by Deb. This is going to be a pretty simple talk because there's a bunch of technical aspects that need to be made accessible. But we're going to follow this pattern. We're going to talk about who, what, where, when, where, why, how. And we're going to focus a lot on the why and the what, as is usual. Let's begin with the who. Who is this talk for? You spend your time to come here at TMLS, and you've been at different talks, and who is this talk built for? When I created this talk, I created this for engineers, architects, and leaders in technology capacity, and basically work with code, data, and infrastructure. That's been my career throughout, and even though I work in product management, I have an engineering background, and I've worked in different spaces, and you can see probably e-commerce, manufacturing in some companies in Canada, some in the US. Let's talk about when and where this is applicable. So when you're building products, I mean, we've been talking a lot about machine learning models, LLMs, how to fine-tune them and things like that. And if you think about an enterprise or any business, how they are operating, that's just a small piece of that, is that not? There is an entire system, an engine, if you will, which is running the business, and there is data that is flowing through it, and engineers are building software. Now, when we build, we want to, from a product practice perspective, go build MVPs, and we want to take the most efficient or optimal route, if you will, and then we want to deploy a product to validate it. And you can see that there is a growing order of complexity in this slide, because as we start scaling a product, as we start maintaining a product, there are different sets of challenges that come our way, which is why I would want to present to you in that context the necessity of thinking holistically about event-driven architecture. This is not a new principle. This has been around for a while, but data has this problem of, zooming into the trees and missing the forest and implementing monolith after monolith, which we need to glue together. And then we wonder why our stuff's so expensive. Why is it such a nightmare to debug systems and deal with scenarios? Now, you all are experts at machine learning, AI, and so on. So you're familiar with this paradigm, if you will. There's a bunch of things that is happening with the data. You're ingesting data, you're preparing data, you're exploring data, you're building models, and you're serving applications. Now, if you were to take out your phone, which is a pretty powerful computer, as we all know, and order a burger from Uber, this is essentially the application side where there's API, and you need to know how long the restaurant will take to prepare the order. You don't really have the time to wait for perpetuity, and you need to know that your driver is going to be off to the restaurant and bringing you the food. Like, that's the world that we live in, right? And if you think about this, the model training and model deployment is a small aspect of it. So the context of my talk is really applicable in the section that is highlighted. I'm not talking about feature stores, model training, feature engineering, all of this stuff you already have expertise and you've heard a lot about already. But why am I talking about this? Well, the reason why I'm talking about this is that the digital universe that we live in and interact in is a state machine. Right now, I'm speaking to a microphone, you're listening to me, you're probably thinking about something, and if you think about how you interact with applications, this is how it works. no matter how powerful a machine learning model that you can build or how amazing a large language model that you build, you are not necessarily in control as a business of how your users will interact with your product. With what frequency will they come? And you create a product that you scale across the globe and people are using the product. I mean, you might be sleeping while people are using it, but the system never sleeps, right? So the state machine is actually a foundational computer science principle which is seen in a vending machine, right? And this is really something that we need to grasp if we are to build solutions that can scale and bring machine learning products to customers. And do so in a way that our businesses can survive, live to see another day, live to fight another day, and build profitable products. Because at the end of the day, that's another thing that is very, very important. But for some reason, this is a challenging task. It's simple, but not easy. Now, I'll make another claim, which don't throw eggs at me, but all software is procedural. It runs on an infrastructure. Yeah, there is functional programming. Yeah, there is machine learning models. Yeah, there is a DAG of an LLM, which will give you all the answers, and it has become sentient, if you will, in some of our minds. But again, when I'm using the software, when I'm ordering the burger, or I'm telling that rabbit, whatever that product was that was hyping out LLM, I'm placing an order, well, it's creating a set of steps, is it not? It's creating a procedural set. And the model has to execute in that context. If it goes out of that context, well, if your driver did not reach you with your food, you're still hungry, right? So we work with software that is procedural, and we work with states. Finally, this is the other thing. We've talked about trust. We've talked about anonymization. We've talked about computational strategies. The thing is that with data products, and my past 17 years working with data products in different forms, operational analytics, AI, ML applied, whatever it may be, the biggest challenge at the consumer level, at the user experience level, is trust. And it doesn't take long to lose trust. In my last role, I was working at this e-commerce intelligence provider. We were scraping 1 billion products on Amazon, anywhere from every few hours to daily to weekly. And we had 1,600 machine learning models orchestrated that would predict how much unit sales did a particular product have on a given day, and therefore how much revenue. And the product has a lot of customers, and we actually grew the B2B product, the enterprise product, to $10 million within 2 years, less than 2 years actually. But it would just take a small thing, a change in the page of Amazon, or a change in the page of someone's Shopify store, a change in the page of Walmart, wherever we are getting our data from. And then the customer would tell us a week later that, I don't believe this data because I'm selling this product and you're showing me garbage data. So the point is that trust requires a degree of control and flexibility. And when we are working with, again, every product that you interact with today, before I go to the what, requires you to bring in data from different sources, bring in procedures from different sources, and combine them to deliver a personalized bespoke experience which each and every one of us expect out of the box. Self-serve. You bring out your phone and it better work, right? And therein lies this challenge with thinking at a level of abstraction whereby you're doing no code, low code, serverless. All of these are great to get started. But the point is, none of that will help you scale. And so I'm bringing you this word which is essentially more than 2 decades in software, right? Which basically every business today wants to reduce their infrastructure overhead, to increase their development velocity, and to enhance fault tolerance so that you can deliver applications baked with functionality, which is AI, ML, whatever it is, and I'll show you more details of that. But it's very important that you get this understanding of why do we need this. And it is no longer okay with the rate of innovation of AI, LLM, all of this, for us to think of this as an afterthought. We are already starting to think about security from the beginning. We're already starting to think about infrastructure from the beginning. And this is something that we need to do. We need to go to the first principles of software engineering and computer science, that's not an option, because that's the moat. That's the moat today. Everyone can go to YouTube and take a boot camp and do API programming, if you will, and build functionality. When that functionality doesn't work, what do? So that's basically what we are talking about. And I told you in the abstract of the talk, or you saw that, this is about how big tech have already been doing this for the past 20 years, right? So this is from Amazon. I'll give you a few examples, and we can have a discussion around this. They have been doing this for a long time, right? So what is an event-driven architecture? The basic premise is that you have this notion of topics. There is an enterprise service bus or an event router. This is from Amazon's AWS's page, and they give you this use case. And the idea is that you are collecting or integrating different sources of data where the events or interactions are coming from. And then that gets routed to a decoupled, essentially, event repository. This is a distributed log, right? And that router, essentially, a combination of a distributed log, which is immutable, that keeps all of the details of what has happened in transaction, and a message queue, which you can access, right? And then you can do all of these different things. This is essentially the diagram of microservices architecture. If you're not familiar, you should look it up. I would argue that data has this problem where we have too many monoliths glued together, somehow to mimic microservices, but they are synchronous, and they're causing all sorts of problems when there is an impedance mismatch. What is an impedance mismatch? Okay, you use a tool to connect to a data source, and you say, get me this data. That tool applies some kind of opinionated modeling on top of that data. Now you bring another tool, and you say, okay, I'll take the data from this tool, and I'll start applying some transformations on it, and you're going to write your business logic, which will then has to serialize, deserialize over and over again, and you're going to make copies of that data. No wonder why we're not profitable, and it takes forever to debug and troubleshoot everything. Now, there's a reason why event-driven architecture is not ubiquitously used everywhere. There's a reason why. Because it's easier to start with a monolith, right? And it's extremely complicated. This is actually from Netflix. By the way, I'll share the slides and all of the links to their engineering blog. This is all official stuff. They have openly shared this, how they built it, right? So Netflix has this, how they get, this is like the centralized heartbeat of all their data. And if you use Netflix, you know how they give you that experience. This is another one where Uber essentially shows how when they send app updates, they detect crashes. So if they updated the app for all of us and a few of our apps crashed, they want to know the log so that they can essentially fix the experience while we don't even know about it. And this is the other one where they serve ads. What do you notice in this? Do you see the reason why we have not been able to implement it in smaller contexts, this pattern ubiquitously? The reason why is that this actually requires all of these companies to at least use 5 or so different tools, one for data integration on the other side, to then go to the Kafka topics, then run Flink jobs, then Hive to serialize, deserialize data. And this is literally like the bane of my existence. I got into big data back in 2009, 2010, and was so enthralled by it, right? Taught people how to implement this stuff, and then started maintaining some of the applications that we built, and started detesting the pager that would keep coming when applications would break, right? Does this all make sense so far? If you think about the LLMs that you want to productionize, if you want to do the prompt injection and the optimization, what are you doing? All of these are DAGs, is it not? And you don't have an orchestrator. You don't have record of the data. You're going to keep on asking questions of every API that you've built patterns and expressions with, and go and try to figure out troubleshooting. When you start scaling, my goodness, it's going to be a circus, isn't it? And it's okay if it is a circus, but I mean, it better be good, like Cirque du Soleil or something. Otherwise, it's just going to be a zoo. It's ironic that the systems, we are talking about Kafka and Flink and all, there was a literal project in the big data space called Zookeeper, which was to tame all the animals in there. But let's kind of transition, and I want to leave a bunch of time for Q&A and make sure that the operations are tight here. I'm representing a real-time engine, so I'm going to make it lower latency, right? So let's talk about how we are doing it. I literally got into this job, year and a half back, I came across this project 2 years ago because of this, that you see how expensive it is to process data, how complicated it is, and for good reason, right? And what you want to figure out is what are the dimensions of simplicity that you can apply to it. And people will talk about these 3 pillars, right? People, process, tools, right? People, talent, who are all well-versed in a particular skill set. Process, how we apply operation, how we build this supply chain, and so on. And we want to legitimately and for good reason focus on people and process, upskilling and having good process. But something that has happened over the last 15, 20 years is basically, if you look at the tooling, it's basically what comes from the big tech and research publications. We are, Hadoop was a Google white paper. Most of it is Google white paper. This is data flow. And all of these things have come from big tech companies. And they are great learning, but we have not necessarily taken the additional step to contextualize it to what we need and how we can actually implement it and maintain it. And then it becomes like too complicated for a smaller company or a mid-sized company to do, and we are left with a Frankenstein data stack and code spaghetti and all these things. So this is how we think about doing it now. And this is not a plug for a product. I'm just showing you use case patterns, and I can show you actual architecture diagrams of how we are doing this today. For the past 5 years, the co-founders of the company that I work with have been underground trying to implement a form of Apache Kafka, a form of Apache Flink, and a form of Apache Airflow. One is a streaming engine, one is a stream processing system which does unbounded stream processing, and one is a workflow orchestrator. As modules, because the shift in overall data, hardware, programming language, infrastructure, and so on, called for a reinventing of the wheel. This has not been so for machine learning community because NVIDIA is an amazing company which has been innovating like crazy for the last decades together. And so you see like every next conference, you see new libraries and new stuff. But the rest of the data world was kind of stuck in the Java age, which still is. So whatever you can do today is limited by the JVM, and we saw that there are new instances if you're an infrastructure person, AWS has Graviton, which is like much cheaper, smaller instance, which works much better. We know hardware has improved. We know there are better programming languages like Rust and Zig. Rust is quite mature. Zig and outside there are boots, and people are all moving to Rust or already using Rust and so on. And so the co-founders of the company, and I found it was hilarious, right? They were running service mesh at Nginx. So Google scale microservices, and they absolutely hated Kafka with their guts. So they're like, no, we are going to re-implement this thing before I knew them. And they implemented this open source project called Fluvio. And when I saw it for the first time 2 years ago, and I'm like, this seems like a work of art. Rust code is not pretty to look at. It's very verbose, and I've left my programming days, and I'm like, okay, what is this thing? But when you actually compile that, few 100,000 lines of code into a 37 MB binary, and it just, deploys in a single command and starts running, I was like, oh, I see. So I'll show you 3 patterns, okay? There's an e-commerce company, or there's the IoT company. This is like the pattern. You integrate data sources, and you have clients, and this is basically a developer product, right? And then you do pretty much everything that I showed you in the previous architecture, nothing to do with model training or model tuning, but you can do inferencing, right? You build data flows whereby you ingest the data, you process the data in flight, you write primitives to filter, map, join, whatever, and you can run machine model inference, right? And I'll tell you how. So this is an e-commerce example. So I'm working with this company in Europe. They get data, and by the way, if you have a Shopify store or WooCommerce store or whatever, and you have Facebook Pixel, when you hit the API, it gives you like a couple of gigabytes as payload. It's like an insane amount of data, and you don't want all of that. So they have like, obviously, we have a Python client that they're running, and then they just want to show like a dashboard to their customers of how is your business doing. That's it. And how is your business doing is answered by what are you selling, what are you losing in your sales, So cart abandonment, stuff like that. What sales are coming to your business account? How much money do you have? What can you allocate to grow your business, procurement, and so on? So you need 3 sources, basically. You need your cart source, you need your payment processor, you need your settlement, because the processor and the settlement, as we know, has a gap. I don't want to bash on banking infrastructure, but we know that it's kind of old. So we get that data, and then we apply filtering on the different messages. Deduplication happens using Bloom filters and key-based. And then we enrich the data from these different sources, and there's a dashboard. Now, their old design essentially was using a Kafka-type pattern. They use that as a dump pipe, and then they would write a lot of scripts, lambdas, to clean up, and then load it into an OLAP data store and run queries every time someone refreshed their graph. And the CTO was like, I actually made this design, but I hate it. So we actually helped him to kind of get a better design. And they're integrating with an OLAP store, StarRox, Apache StarRox, if you're familiar. And this is like 80% of our bread and butter today, IoT. So I was really glad to see a couple of companies outside who are talking about real-time and IoT stuff. So the interesting thing about Fluvio is that the 37 MB binary, which compiles to this streaming system, it can be deployed on an ARM v7, whatever device. Yeah, device, Raspberry Pi, whatever. And it can actually do this computation stuff on device. So you don't really need to pull all the data from edge to core, because there are guys who are making digital twins of boats, and the boats are in the ocean, and they have their device with MQTT and InfluxDB, and 2 days the internet is down, and they're losing data. Okay, so we basically implement the MQTT broker first. Then we actually say, okay, fine, just run the binary on your device, like get the data directly in. And what they do is quite simple, and this is something that everyone wants to do, from stockbrokers to whatever, whatever sensor data you're looking at. You basically want to filter the data, group them, and you want different time resolutions of it. What happened in the last 30 seconds, what happened in the last minute, last hour, average, and use those averages to basically figure out deltas to predict anomalies, right? And this is all happening in our benchmarks in nanosecond, but obviously overall in the pipeline, sub-second latency. This is the final one. I mean, I'm at a Gen AI conference, so I don't want to, be the one who commits this blunder of not talking about Gen AI. This is not our predominant use case, but there are people in our community who have built basically patterns where they would get data from the Wikipedia stream. It's available. Then they will summarize it by making an OpenAI call. They'll split the text. Then they will create their own embeddings and load it into a vector database like Quadrant or something like that. And Fluvio essentially is the streaming system and the engine that is orchestrating all of this. Okay? And I just want to talk about one thing about the experience, and I'm done, and I can take questions. The core project, this is the streaming engine, is open source. The stateful data processing, which is like if you have streams of data, you're getting payload, and you're doing bounded and unbounded processing, that is free to use, but not open source, because our competitors were essentially trying to build the same thing. But basically, if you think about data transformation, you just break it down to 3 things. There is your business logic, what do you want to do to that data, the schema, okay, and how you want to manage state if you're doing time-based computation. There are only 3 things. The schema is made out of data types. State is what is happening record by record timestamp, and what is the series of business logic or transformations you want to do. In a production system, it's really like, what is your workflow of if that, then that. You can think of this as a glorified Zapier, if you will. And so we basically built that experience using the WebAssembly component model so that you can work in the programming language of your choice that we support. And so what you do is you basically define your schema, your data types, and you define your business logic in the language of your choice, and that compiles to WASM binaries, which is language agnostic. And then what that does is it runs on our Rust engine, and Rust and WASM thankfully has very tight integration. And therefore, what you essentially have is an elegant system which you can now build as developers in a declarative way. The experience is like Ruby on Rails, but for data pipelines. And that's basically it. So all of these things to say, and this is like a bento link you can scan and connect with me or whatever. All of these things to say that you would need event-driven architecture. We are trying to make this possible for you to start with event-driven architecture from day one. And the reason for that is when you put together a bunch of database and serverless code spaghetti and you try to scale an application, I can guarantee you that. I mean, I can give you money for it, that you're going to start losing money and you're not going to scale. I have seen the worst of it in the last 17 years. And this is kind of my mission right now, to evangelize. And if you need any help to implement something so that you can just try out, again, open source project, free to use. If you need any help, let me know. Open to taking any questions. Thank you.
Hey, Dave. Thank you for the presentations. Interesting. One quick thing regarding the cost you were mentioning. With bare minimum, how much is it going to cost?
Oh, well, we don't charge you for storage at all. Like, we have tiers. Yeah. So if you have a cluster, you can actually start. Local is free, obviously, community edition. But if you started at our cloud, we actually charge startups like a $500 cluster fee, and we give them 3,000 credits. And what that gives you in terms of throughput is you'd be able to process, like, say, tens of thousands of messages a second and operate for like 90 days. So it's extremely affordable to try and get started. Now, where things become more expensive is if you start managing state and cache the entire thing and your state grows, because we are a processing play. We over-index on processing because that's where you get most value, and that's where you need to be more deliberate. So yeah, again, summarizing, get started pretty easy, $500 or so. We had a bunch of free credits that we give out to startups and so on. And yeah, it's not, if you compare us like with the Kafka, Flink, Confluent, Red Panda, we are like half of that.
Yeah. Thank you. It's a really amazing presentation. Thanks for sharing your wealth of experience. You mentioned in one of your earlier slides that there were usually 5 components that, and from the top of my head, I can think of, well, you definitely need a message broker. That's what your Kafka is. You would also need an event store.
Yes.
So a NoSQL database of choice could be Cassandra or something else.
Sure.
And also some sort of like real orchestrator, right? Like Zookeeper wouldn't really do the job. Maybe for that you would have Kubernetes or something like that.
Yes.
That would also enable the auto scaling and all that jazz. But what other such components are, as from your experience, the kind of like the Achilles heel in an implementation of this? And last question, does Fluvio have a Kubernetes deployment? Can you deploy Fluvio to
got
Kubernetes?
it. Kubernetes, yeah, right. Sure, yeah, absolutely. Yeah, we deploy it, it's cloud native, so we deploy it to Kubernetes, and we are on AWS, on GCP. That's how the deployment works. We actually had a dependency on etcd, which is the key value store used by Kubernetes for a big part of our existence. But we needed to decouple and present a single binary because developers wanted to try with a leaner engine without Kubernetes locally and deploy on Nomad, Docker, whatever. So now that was like released maybe a year ago or 6 months. So we deploy in Kubernetes, yes, and we separate control plane, data plane. We can do local, hybrid, all of that. Here, if you look at this diagram, so Kafka's biggest problem is obviously partition balancing, right? That's where, and running out of memory. Hive's biggest problem is because you want to enable all the data people to write SQL and get that translated into whatever, you're actually paying the cost of serialization, deserialization. That's what is happening multiple times. You're making new tables and you're just going serializing, deserializing. So in essence, everyone says storage is cheap, processing is where it's expensive. Well, actually, they're just hiding that, right? And then when you talk about Flink, the impedance mismatch come like basically what I find when I talk to people is that they find that there's a broken Flink job, and this is the reality in Uber. It has broken because it's run out of memory, and we saw like run out of memory exception in CUDA as well. That's because of the JVM, right? Now it actually happened because Kafka partition got rebalanced or awkward. So now you're like troubleshooting throughout your entire pipeline to find like all of these changes propagating through it just to give a basic application. I mean, it's like a nightmare. That's why most smaller teams don't adopt it. But we think this is the right pattern, right?
Deb, thank you so much. Another round of applause for Deb. Thank you so much.